Chapter covers the following topics: diagnostic reporting and status LEDs. Completion of this chapter will help you learn how diagnostics simplify the operation and maintenance of PROFINET networks. PROFINET network and device diagnostics improve both the startup and ongoing operation of a plant or machine. This includes diagnostics in response to an error condition and diagnostics used to check the status of an automation system. In combination, these diagnostics reduce startup time, network outages, and downtime, resulting in increased productivity and, most importantly, increased profit. PROFINET device diagnostics take place in the following four levels as shown symbolically in the accompanying graphic. 1. Device-level diagnostics identify I/O device errors. 2. Module-level diagnostics identify module errors within an I/O device. 3. Submodule-level diagnostics identify submodule errors within a module. 4. Channel-level diagnostics identify errors associated with a channel of a module. PROFINET network diagnostics provide information about network status and error conditions. This information is communicated using Simple Network Management Protocol (Snmp), a widely used Ethernet protocol for the monitoring and management of networks. Snmp is also used to access the network topology information gathered at startup via another widely used protocol, Link Layer Discovery Protocol (LLDP). This allows useful network status information to be available in a variety of ways. For example, the current network status can be viewed using an engineering tool, such as Step 7 and TIA Portal. PROFINET provides flexible approaches for accessing and responding to diagnostic information, enabling the rapid localization and resolution of any error condition. For example, an I/O supervisor, such as a programming device, personal computer, or HMI device, can request the station status of an I/O device from its I/O controller or directly from the I/O device. If the I/O controller has a built-in web server, a variety of diagnostic and status information can be easily accessed remotely via web pages. Additionally, because an I/O device sends all error messages to its I/O controller, automatic responses can be triggered via the user program in the I/O controller. In addition to the diagnostic reporting approaches discussed thus far, Siemens also offers software for monitoring and controlling industrial networks. Among the products that fall into this category are Snmp OPC Server and Cinema Server. Snmp OPC Server software provides diagnostic and configuration functions for all Snmp devices. All information can be integrated in Open Process Control OPC compatible systems such as the WinCC HMI system. This enables process and network diagnostics to be combined in the HMI system. Cinema Server is designed to document and increase the availability of networks, as well as for the integration of network diagnostics into supervisory control and data acquisition SCADA systems. Cinema Server enables the quick identification of communication problems in wired and wireless industrial Ethernet networks. With Cinema Server, diagnostics are accompanied by continuous logging and archiving. Information collected in Cinema Server can be displayed using a standard web browser. What do you think? Select all the correct statements, then click Evaluate. In addition to the various diagnostics previously discussed, status LEDs are provided on PROFINET interface modules and some additional devices. The specific LEDs on a device vary somewhat with the function of the device, but the following status LEDs are common. 1. SF, system fault, lights up red to indicate that a system error is present. 2. BF, bus fault, lights up red to indicate that there is a bus error at this interface. If the BF LED on an I/O controller flashes, one of its I/O devices has an error. If the BF indicator on an I/O device flashes, that device has an error. 3. RxTX, receive transmit, lights up yellow to indicate the data is being received or sent. If the data volume is low, the LED will flicker yellow. 4. Link lights up green if another device is attached and the physical connection is operational. Depending on the device, additional status LEDs may also be present. For example, the accompanying graphic shows an interface module with the following status LEDs. 1. Error FO, fiber optic error, often shown only as FO, lights up yellow to indicate a fiber optic connection error. 2. On, DC power on, lights up green to show the DC power is being provided to the module. If this light is off, all other indicators will also be off because the module does not have DC power. These are only examples of additional status LEDs. Refer to the documentation for the specific device or module for additional information. What do you think? Drag the blocks to correctly complete the statements. Then click Evaluate. This chapter has provided you with an overview of PROFINET diagnostic reporting and status LEDs. This information is important because it summarizes how diagnostics simplify the operation and maintenance of PROFINET networks.